Hey, class, let's take a look at this next section on sinusoidal curve fitting. So we want to be able to create a graph from some modification of the original sine or cosine. And we're adding this idea of a phase shift. We've already looked at like the amplitude and a period. We're going to add this notion of a phase shift, which is just going to take the graph and scoot it left or right. So in summary here, we've got the amplitude as the absolute value of whatever that constant is. And then the period we called capital T, and that's the original period, 2 pi divided by omega. And then our phase shift is new, and we calculate that by taking some value that's being added or subtracted inside the parentheses here of the sine or cosine function. And we'll take that value and divide it by omega. This symbol is called phi. So phi divided by omega. And this gives you a key right here that we're going to shift to the left if phi is negative, and we're going to shift to the right if phi is positive. But don't let that confuse you, because if phi is negative, this would turn that into a plus, right? Because this would be minus negative something, and that would become a plus. So we're worried about what phi is if this symbol is subtraction. And so with the subtraction there, if the phi value is greater than 0, it's going to shift right. And if it's less than 0, it's going to shift left. Okay, and then we've got a step-by-step here as to how to do this. So let's just apply those steps. We're going to take a little example here. Okay, so we've got y equals 3 times the sine 2x minus pi. And so remember that in our little system here, this symbol here is represents phi, and then this is omega. So first of all, the amplitude. Okay, so that's 3. And we're going to find the period. T is equal to 2 pi divided by omega, and in this case, omega is 2. Okay, so our period is now pi because of this factor. And then we're also going to calculate the phase shift. Okay, our phase shift is going to be phi, which is pi in this case, divided by omega, which is 2. So there are the components that we're going to use as we recreate this graph. Okay, so what we've essentially done is this step 1 here. We found the amplitude, the period, and the phase shift. So for step 2, we need to have the start point. And that's just going to be the phase shift. Okay, because that's the phi over omega. So we're going to start now, instead of at 0, we'll start at pi over 2. That's where everything's going to begin. And the end point is going to be pi over 2, where we begin, plus the period of pi. So this is all going to wrap up at 3 pi over 2 to get through one cycle. Starts at pi over 2, ends at 3 pi over 2. Okay, so now what we need to decide, we've done this part, we figured out where it starts and where it ends. We have to divide it into equal subintervals. And so the length of a subinterval is going to become, it's going to be the period divided by 4. Okay, so our period in this particular case is pi. So if I take pi and divide it by 4, this is the distance between the key points. And then we know that we start at the key point pi over 2, and if we count by pi over 4s, the 5th point is going to be here. and we'll have the key points in between. So we'll start at pi over 2, count by pi over 4s until we reach 3 pi over 2, which takes us through one whole cycle. Okay, so now we're ready to embark on step 3 here. So step 3, we have to use the endpoints to find the total of the 5 key points on the graph. Okay, so we start at pi over 2, and the next x coordinate is going to be pi over 2 plus pi over 4. And the one after that is going to be, well, let's go ahead and calculate this one first. So if I take pi over 2 plus pi over 4, pi over 2 with the denominator of 4 would be 2 pi over. So this is going to be 3 pi over 4. Okay, and then this is going to be 3 pi over 4 plus another pi over 4. Okay, so that's going to be 4 pi over 4 or pi. And then we're going to take pi plus pi over 4. So 4 pi over 4 plus pi over 4 will be 5 pi over 4. Okay, so we should arrive at 3 pi over 2 next. So I'm going to take 5 pi over 4 plus another pi over 4. That's 6 pi over 4. And if we reduce 6 pi over 4, we get 3 pi over 2. Okay, so we've got all these key points. I'll just copy the pi over 2 back down here. So we can see that the x coordinates of our key points begin at pi over 2. We count by pi over 4 until we reach the end of a cycle at 3 pi over 2. Okay, now let's remember what one cycle of the regular unmodified y equals sine x. The x value we started with was 0. The next value was pi over 2. The next was pi, and the next was 3 pi over 2, and then 2 pi was our full cycle. We modified that now so that everything starts at pi over 2. It's shifted over to start at pi over 2. And then the next key point is at 3 pi over 4. And remember, we're counting by pi over 4. We added pi over 4 to each subsequent x value to get the next to complete a cycle. So these are our x values. Now, what happened to our y values? Well, in the function we're working with, they got modified by the amplitude. And not only that, it's positive, so we didn't flip the direction. So we're still going to have the next key point after the one that starts at pi over 2 is going to be at the max. And we multiplied that 1 by a 3. So we're going to take and write our key points here. We have pi over 2 for x, 0 for y. The next key point is now at 3 pi over 4 for x, and we're up to a 3 due to our amplitude to replace that 1. Third point, pi, we're back to 0. And then 5 pi over 4. This takes us to the negative 3, the bottom. And then from there, we go back up to 3 pi over 2. And we're back at 0, ready to start a new cycle that we count by pi over 4s to get to subsequent key points. Okay, so we've got the 5 new points, and we want to create a graph as our last step here. And remember, our graph is of this function here, y equals 3 sine quantity 2x minus pi. Okay, and so if we think about where this is going to translate, we'll go ahead and create a graph. And remember that between key points, it was pi over 4, so it makes it convenient to step by pi's over 4, pi over 4s on our x-axis. And we know that the amplitude is this 3, so we'll take it up to the max of 3 and the minimum of -3. And remember our first point, so is pi over 2, 0. So the modified graph is going to shift over. Instead of starting in the origin, we shift over here and start at pi over 2. Each new key point happens at an interval of pi over 4. So the next one happens at 3 pi over 4. And the tops out at 3. So we have 3 pi over 4, 3. And this was pi over 2, 0. And the next key point happens at pi, and that's a pi 0. 5 pi over 4, we get our -3. So that's 5 pi over 4, -3. Get another 0 here at 3 pi over 2, and that ends one cycle. Okay, so let's sketch that cycle in. All right, and if I want to extend it a little bit, I just need to step by pi over 4, and I know that the next place I go at the next step is back up to the 3. So it's 7 pi over 4, which is we've already started a new cycle, and so that's the next key point, and that's going to be at 3. And then, of course, at 2 pi, it's going to reach back down. And then you can just put a little arrow on that saying that. And then, of course, down here, if I go backward by 2 pi, I'm back down at the -3. So pi over 4 has an x -3. And then this is going to shoot through there. And we could just kind of put our arrow in. Okay, so let's go ahead and label this graph. It's the graph of y equals 3 sine quantity 2x minus pi.